In this video, I'm going to solve another A-level physics question that is related to AQ exam. First of all, I read the question and I will explain. A tennis ball is thrown vertically downward and bounces on the ground. The ball leaves the hand with the initial speed of 1.5 meter per second square at the height of 0.65 meter. Okay. For example, here is a tennis ball and we throw the tennis ball with the speed of initial speed of 1.5 meter per second, and this ball going down, and its speed increases. As we know that the ball, when the ball goes down, its speed increases before striking the ground. The ball speed, we have to find the ball speed. Okay. And this ball bounces off back, and it reaches to the same height. Okay. And when it reaches to the same height, the speed that is given, it travels upward with the speed of 1.0 meter per second. So after returning, its speed is 1.0 meter per second. Okay, assume the air resistance is negligible. Here we assume that air resistance is very small or very low, mean we ignore the air resistance. Okay, showed that the speed of the ball is 4 meter per second just before striking the ground. So we have to find the speed v before striking the ground. Okay, so in order to find this speed, we just use the equation of motion. First of all, I will write the data. So initial speed, that is equal to 1.5 meter per second. Final speed, that is need to be find. We have to find the speed v just before striking the ground. The acceleration is gravitational acceleration, that is equal to 9.81 meter per second per square. And so we apply the equation of motion, that is equal to 2as is equal to v square minus u square. So we put all the values. So we have to find the v square, so we just rearrange this equation. So v square is equal to 2as plus u square. So we just put the values 2 into 9.81 into distance that is given, the height that is given. Here the distance is 0.65, height is 0.65. Between these 2 points, between here to here, the height is given, that is 0.65 meter. 0.65 meter plus v, that is 1.5 square. Okay, so v square is equal to, then we solve this, and when we solve this, we get 15.0. So we take square root, so we get 15 square root, we get v is equal to 3.87. so when we round off and we get answer, that is equal to 3.7. and if we round off to one significant figure, that it give us 4.0 if we round off to one significant figures. So here that need to be found. The show the speed of the ball before hitting the ground is 4. That is, our answer is equal to 4. Now for the part II, the ball is released at time t is equal to 0. So it means the ball here release, the time starts now. It hits the ground at any time, that is ta, and is caught at the time tb. So here just before hitting the ground, when it hit the ground, its time is ta, and when it is caught at the highest point at the speed of 1.0, its time is tb. Okay, so on the graph, here is the graph that we have to sketch the graph. The x and y points are marked. X point is when the ball is released from the height. Okay, so it means when the ball is released, this is x point. Okay, so when ball goes down, and when ball goes down and it strikes with the before hitting the ground, so its initial speed is 1.5 meter per second inverse, and its final speed is 4 meter per second inverse. Okay, so we just draw the graph. Okay, as we know that acceleration means the speed that is increasing when the ball goes down, its speed increases. Definitely speed increases, and when it goes down, so its speed increases. It means the value of g, that is constant, mean acceleration is constant, Acceleration means change of speed, yeah, or change of velocity. That is constant. In this case, we know that g is 9.81. That is constant. That needs to be constant. It means our graph must be a straight line. BT graph must be a straight line, and this straight line is between 4. TA is here because this is the t time TA. Okay, so here is the time TA when the ball strikes the ground. So we just draw the straight line between these 2 points. Okay, we have to remember that we have to just draw the scale. We have to just draw the straight line. Okay, so straight line will be like this. Okay, straight line will be like this. Okay, it will be downward. Exactly straight line, if I'm not wrong. So this is the exact straight line. Okay, now when the ball goes up again, okay, so ball reaches at the point, this point, that is 1.0. The speed, final speed is 1.0 meter per second. As we know that there is a change of speed, that is instead of 1.5 it is 1.0. So it means, it does mean we have our actually the acceleration is also same. Now when the ball goes up, so acceleration is again 9.81 meter per second. Okay, so it means the slope will be same. Slope will be same. So we have to draw the, if we look at the slope of this line. Okay, on the y-axis our point only increases 0.25, mean half point. Over our on the y-axis our slope will be only the half of this box. Okay, on the horizontal axis our increment is complete box, mean y-axis is only the half. On the x-axis we have only the complete cycle. Okay, if we look at this, only y-axis we have half, only x-axis we have complete. Okay, so only on the y-axis we have the half. Okay, so when we look at this, when we increase the slope and we go and until we reach at the 3. Actually I did not draw the accurate value, so I repeat this. Okay, I repeat this. On the x-axis we have 1, y-axis we have the half. On the x-axis we have 1, y-axis on the half. Okay, on the x-axis we have 1, and on the y-axis we have half. Okay, on the x-axis we have 1, y-axis on the half, or axis is 1, y-axis with the half. 1 and half, 1 and half, 1 and half. So over, when we draw these lines, we get 3. Our final speed is 3.0 meter per second. So confusion is that why there is 3 speed. It should be 4, but remember that our final speed is less than before that. It means there is some loss of energy. There is loss of energy. It means that's why the and other thing is that the slope, this gradient must be the same. The gradient is same for both cases. So if gradient is same for both cases, so when we draw these graph and we our final speed will be 3. So it means our this speed must be equal to 3. Okay, thank you. Mean when the ball rebounds back, its speed is not 4, it is 3.0 meter per second, because there is loss of energy, because instead of 1.5 it is the speed is 1.0. Okay, thank you. So confusion is our speed, why it is 4, not 4, because when we draw the same straight line, when we draw the same gradient straight line, so it means the graph must be reach at the 3, not the exactly equal to 4. Okay, thank you.